All right, we can use trigonometry to find the side lengths if we know what this angle is. That is one of the other angles that is not the right angle in a right angle triangle. We have called it theta when we were looking at those relationships, those ratios of sine, cosine, and tangent, and how the different sides relate to one another and give us the ratio. Well, now we can use having the angle itself to find out what the other sides are. So first we have to use our calculator, and I've got my calculator here. So if I'm going to plug in, if I want the sine of 50, let's clear that. The first thing I want to make sure is that my calculator is in degrees mode. And if you're using the Sharp calculator, we recommend this little button will change that. You probably will be in degrees mode, but if you watch up here, if I hit this, that's then in radians. And I don't know what that is, gradient maybe, but we want to make sure we're in degrees. So if I want to find sine 50, it's as simple as pressing the button that says sine and putting in 50 degrees, and that's going to give us a number. And that number is huge, 0.76660. And if I look at my instructions, we want that correct 2 decimal places. So 7 and 6 are my 2 decimal places. But if I look next to that, my critical digit here is 6. And anything that's 5 or up will then push this rounding number up. So it'll actually be 0.77. And then we'll do the same thing with cosine. So we'll clear. We want cosine 16. So we're going to hit, again, we'll make sure we're in degrees. The cosine of 16 degrees is another big number. So again, we're told we have to round to 2 digits, 0.96, and the critical digit here is less than 5, so that's going to remain 0.96. And finally, tan of 77, clear, still says degrees, tan of 77 is going to be equal to a big number, and we're going to, ooh, look at that. That's going to be equal to 4.33. The critical digit is 1, so that 3, and that's less than 5, so the rounding number 3 is going to stay as a 3, and we would say we would round down. Okay, if the angles on one side length of a right-angled triangle are known, then the other side lengths can be found using these ratios, sine, cosine, and tan. For each triangle, find the value of x. So first of all, we need to discover which sides we have. We have the adjacent side here, we've got the hypotenuse here, and then we've got the opposite side over here. So I don't know what a equals, but I have an O and I have a h. That tells me I'm looking for the sine. So the sine of 38 degrees, the ratio that we're going to get, is going to be O, opposite side, over h, which is, our opposite side is x, and 7 is our hypotenuse. So let's get rid of that. So sine 38 is going to be that. And what we want to find out is the length of x. So algebraically, what are we going to do? You know what we're going to do. If we're dividing by 7, we're going to multiply by 7. And I'm going to swap sides because I'm in the mood. Doesn't matter. X is then equal to 7 times, I'll just write it next to sine 38. So then on my calculator, 7 sine 38, and bingo, bango, bongo, I get 4.309. And again, I think we'll be told to round to 2 decimal places. So here we've got 4.309. That's going to bump that out to 4.31. So therefore, x is equal to about, I should probably be writing wavy lines here, 4.31. Oh, yeah, it is 2 decimal places. Look at me, I'm ahead of the game. And now I've got this, 42 degrees, and what have I got? I've got opposite, and I've got adjacent this time. So if we've got opposite and adjacent, and we don't have a hypotenuse, then we're looking for tan. So the tan of what we have is 42 degrees is going to be SOHCAHTOA, opposite over adjacent. So replacing that with the opposite is x. The adjacent is, looks like a 4. Clean the glasses. And again, I'm just going to jump to conclusions here. We've got x over 4. We want x by itself. So we're dividing, so we multiply by 4 tan 42. And again, I've got my calculator all set up. 4 times the tan of 42 degrees. Making sure we're in degrees. That's going to give us 3.60. The critical digit there being 1, so I don't have to round that up. It's going to be 3.60. And the answer will be 3.6 with the 0 on it, because we want to make sure if we're asked for 2 decimal places that we give 2 decimal places. So that's why that 0 remains in there. And finally now, we've got our angle here, and we are dealing with a hypotenuse and adjacent. So when that happens, we've got to do cosine. Because cosine of this angle, what is it, 24, is going to be equal to adjacent over hypotenuse. So what's that going to be? X over 10. You can probably tell what I'm going to do. I'm going to do a little swapsinator. I'm going to multiply both sides by 10 times the cosine of 24 degrees. And the calculator does its magic. 10 cosine 24 equals, and that gives us 9.135. And because our critical digit after the 3 is 5, that pushes that up. So x is going to be equal to 9.14, which is accurate to 2 decimal places.